Hello everyone, I am Haiying Che from Institute of Data Science and Knowledge Engineering in School of Computer Science, Beijing Institute of Technology. In this session, we will discuss big data general architecture. When the volume of data gets bigger and bigger, any single traditional high-performance server cannot satisfy the requirement. More servers are needed, but the traditional high-performance server is very expensive, normally hundreds of millions yuan. Because it is very reliable, like IBM Z-series server, which can reach the reliability of 99.9999%, known as zero downtime. So it is called Z-series. High performance and high reliability means high price, but no company can afford such expensive server to deal with the big data issue. So the distributed computing was used to address this issue. The logic of distributed computing is use a group of cheap servers working as a team to replace the expensive high-performance servers, which could be distributed processing, distributed storage, and use high redundancy to achieve high performance. Key hardware and software breakthroughs revolutionized the data management industry. First, innovation and demand increased the power and decreased the price of the hardware. New software emerged that understood how to take advantage of this hardware by automating processing, like load balancing and optimization across a huge cluster of nodes. The software included built-in rules that understood that certain workloads require a certain performance level. The software treated all the nodes as though they are simple one big pool of computer, storage, and network assets, and moved the processes to another node without interruption if a node failed, using the technology of visualization. In the scope of big data, there are two main components: distributed storage and distributed processing. The data needed to be stored, then processed, and the intermediate and final result also needed to be stored. These two components complement each other and closely work together. Generally, the big data architecture includes three layers from bottom to top. Data storage systems include distributed database, data warehouse, which store the structured data in relational database, distributed file system, which store the unstructured data, and also the data collection and modeling, and which is responsible for collecting data according to the predefined model. Second layer data processing system include a calculation engine, computing platform, calculation model, and algorithms. Based on the stored data, we need to design the calculation model, algorithm. Also, we need a big data distributed calculation engine like MapReduce, and the computing platform like Hadoop, Spark, Storm, etc., to facilitate the data processing. And the third layer, based on the data storage and the data processing result, the customized big data application can be built, which includes big data applications, data products and services, and also the data visualization. With the help of processing system, all the needed data has already been calculated and modeled. The upper-level application can present the data visualized result, or give suggestions, or make smart decisions. In the storage structure, The database provides the logical storage structure of the data. The distributed file system provides the physical storage structure of the data. Data storage system could include several parts: the data collection layer, system log, web crawler, wireless sensors network, Internet of Things, and all kinds of data resources from which we can collect data. Second, data cleaning, extraction, and modeling. Then we can convert various types of structured, unstructured, and heterogeneous data from different sources into standard storage format data, and define data attributes and value ranges to prepare for the data analysis. And then the third layer, data storage architecture, centralized or distributed file system, relational database or distributed database, row-based storage data structure or column-based storage structure, key value pair structure, hash table retrieval, etc. Data scientists can choose the suitable data storage architecture to store the data, making the data storing and the data retrieval more convenient. And the unified data access interface, etc. The application's access to the database and data exchange is an important issue in distributed computing system. The industry earlier used the Database Application Programming Access Interface provided by Microsoft, ODBC, Open Database Connectivity, which used the XOpen and ISO IEC called Interface Standard as the basis, and use a structured querying language, SQL, as the database access language. ODBC is essentially a set of database access APIs, consisting a set of functions calls, and the call is SQL statements. When an ODBC-based application operates on the database, the user directly transmits SQL statements into ODBC. At the same time, ODBC